Alright, when we name and draw aromatic hydrocarbons, typically you're going to have a parent that has the benzene name in it. Although be careful, because when it comes to benzenes, your rings, you tend to use a lot of your common names as well. Those are widely accepted, like toluene and phenol and aniline. And the other thing you need to know is if you have functional groups or substituents in the 1,2 pattern, we call that ortho, and we use an O to designate it. This is different from anything we've done previously. If you have a 1,3 pattern, that is meta. We use an M designation. And if you have a 1,4 pattern, that is considered para with a P designation. And as we go through these examples, you're going to see that come up a couple times so you can see it in action. Alright, the tricky part about using IUPAC names and then also having common names widely accepted is that this particular molecule would have two names, either the IUPAC name or we could use the common root that we see. So I want to look around and see on this molecule, do I have what would be considered a common, widely accepted name for this? And I do see that. And if I were to look right here, when you have two methyl groups coming off of a benzene ring, this is called xylene. So one way to name this is, instead of saying that it's a benzene ring with two methyl groups and a chlorine coming off of it, you would say that this is a xylene. And it's important that we mention what position those two methyl groups are coming off of in xylene, because it could be in the ortho, meta, or para pattern. So I'm going to number my carbons in a way that gives, since they're perfectly apart from each other, that gives that chlorine the lowest number carbon possible. And so if I start with carbon number 1 right here, that gives the chlorine a 2 carbon. If I were to name it the other way, my chlorine would have a 5th carbon, and that's not the lowest possible number. So you have your methyl groups in a 1,4 position. This is considered para. So I would put a P right before the xylene, and that's just telling me exactly where those methyl groups are. And then the next thing to do is to take care of that chlorine functional group. So that is a chloro, and it is in the 2nd carbon position. So one possible name for this would be 2-chloro-p-xylene. If we were not using xylene as our root, as our common name, we would still call this 2-chloro. We would still mention that we have two methyl groups in the 1,4 pattern, or the para pattern, but this time we would use benzene as our root, and we would actually mention each of these methyl groups by themselves. So you would have p-dimethyl benzene. Now these guys mean the same thing. It's just the bottom one is your IUPAC designation, and the top one uses your common naming for that. So this would be 2-chloro-p-dimethylbenzene. I don't need to say 1,4-dimethyl, and the reason for that is this P tells me that it's in the 1,4 designation, and the di tells us that we have two methyl groups coming off of that benzene ring. Alright, here we have xylene again, and remember, xylene is a benzene ring that has two methyl groups coming off of it, so two CH3s. Meta tells us it's in the 1,3 pattern, so I'm just going to arbitrarily pick a carbon, and this will now become my 1 carbon, 2, and 3. So I'm going to put my other methyl group coming off of the 3rd carbon, because that's what meta means. It means it's in the 1,3 position. This also tells me, I'm going to erase my 3 so it's not confusing, that we have, so that takes care of that entire part of the name. We have a bromine coming off of the 2nd carbon. So I'm going to find my 2nd carbon and put a bromine there. And that is 2-bromo-metaxylene. Okay, so here I see the root xylene, which tells me that I have a benzene ring with 2 methyl groups coming off it. So I'm going to put my first methyl group coming off, and I need to know, obviously my first methyl group always takes carbon 1. P or para is for the 1,4 pattern. So I'm going to count 2, 3, 4, and I'm going to put another methyl group coming off. Don't forget that ring in there, or it's not a benzene ring, it's just a cyclohexane, and then you'd name it completely differently. Just keep in the back of your mind that we are dealing with a common name here, so another name for this would be p-dimethyl benzene. And what that does is it takes the common name and it names it using the IUPAC name, which is benzene for the ring, your 2 methyl groups in a 1,4 distribution.